In this lesson, we're going to start looking at solving equations. It's the first of a couple of lessons on solving equations. The main thing that we want to keep in mind when we're solving an equation, is that we want to isolate the variable. So we want to get the variable by itself. And the way we do it is we look at the operations that we would have. So in this case, we have 2 times x minus 5. The 13's on the other side, so we don't have to do anything to get it away from the x. But we're trying to move these numbers away from the x. So I want to get rid of this 2 that's multiplied by the x, and I want to get rid of this negative 5 or this minus 5 that comes after it. The way I do it, following correct order of operations, is I do the opposite operations, but I have to do them in the opposite order of operations as well. So again, if I focus on the 2x minus 5, we've got to multiply and we've got to subtract. Again, just looking at this part, not worrying about the 13. So, multiply and subtract. The normal order of operations would be to multiply something first and then we'd subtract. So I'm going to do the opposite of that. I'm going to do the opposite operation. So instead of subtracting 5, I'm going to add 5. And when I add 5, that's obviously, whoops, didn't mean that to go away. When I add 5, it's going to get rid of the 5. It's going to cancel out with the minus 5. So adding 5 cancels out the minus 5 there, but I have to do it to both sides. So I would add 5 to the right-hand side as well, and I'd simplify that. So I'd get 2x equals 18. And then the next step is I do the opposite of multiplying by 2. So I would divide by 2. So I'd take the 2x and I'd divide it by 2. That would cancel out that 2 there. And I'd do the 18 also divided by 2. And so x would equal 9. So I've gotten to a point now where I've got the x by itself. Like I said, we call that isolating it sometimes. And that would be my answer. Now, if I wanted to just explain it then, for short, the way I remember it is opposite, oops, 2 P's in opposite, opposite operations in the opposite, let's call it the reverse order though, order of operations. Okay, so an equation is a polynomial expression, remember what a polynomial is, that is equal to something. Seems like we got an extra letter here. Let's see if I can get rid of that L. Equal, no, I guess it's the T that's in there that I need to get rid of. Well, anyway, don't think I can get rid of it. That's not so bad. For example, 3x plus 5 equals 10. To solve an equation means to find the value of the variable. When we're solving, we move everything away from the variable to leave it by itself, called isolating the variable. And when we move anything from one side of the equal sign to the other, we do the opposite operations. I cannot seem to spell today. Operations. The order that we move the values is opposite order, or reverse order, as I said above. So we're just going to look at some examples, starting with the simplest and going to slightly more difficult. X plus 3. So we only have the one operation, we have the plus 3. So I'm going to do the opposite operation. I'm going to use a short form when I talk about it. I'm going to talk about bringing numbers to the other side. Now, we all know that I'm not really bringing a number from one side to the other. I'm doing the opposite operation. But it kind of looks like I'm bringing a number to the other side. It looks like I'm bringing that 3 over. But really what I'm doing is I'm subtracting 3 from each side. So it goes away on the left and it shows up as a minus 3 on the right. But for short, I'm going to say I'm going to bring that 3 to the other side, and I've got x equals 4. And I can check this, by the way, too. I can plug the number back in. Just as a quick check, and we can set up proper left side, right side tables for checking things, but for a quick check, just try sticking 4 back into the equation. 4 plus 3 equals 7, and you could do that on a calculator if you wanted to for a harder one, but that's just an easy check. The opposite operation in this case is to divide both sides by 20. Let's just write it like this. So 4 times x, the opposite of multiplying by 4 is dividing by 4, so x equals 20 over 4, so x would equal 5. The opposite in this case is we've got x divided by 6, so the opposite, let's do that in blue, the opposite would be to multiply both sides by 6, and I'd get x equals 30. And again, if we want to check these last two, 4 times 5 does equal 20, and 30 divided by 6 does equal 5. You can check it on a calculator. Here's a two-step one. So again, reverse order of operations means I'm going to take care of the minus first. So I'm going to bring that 4 to the other side, and I'm going to add it. So I've got 6x equals 36. Then I'm going to divide both sides by 6, and x equals 6. 6 times 6, if I plug it back in, 6 times 6 is 36. And if I take away 4, it equals 32, which is what I was looking for. This one's a little funnier because it's got this minus sign in front of the x, but we can still approach it the same way. So I want to get rid of that minus 4 that's with it. So I've still got a minus sign in front of the x, but I'll bring the 4 to the other side, and it becomes a plus 4. Notice how I'm just tacking it onto the end. So whatever's already there, I'm leaving in its place, like the negative 7. And I'm just tacking that plus 4, in this case, onto the end. Negative 7 plus 4 is going to be negative 3. And I can think of this negative x as if it were a negative 1x. That might be the easiest way to do it. So if it's negative 1 times x, then I could divide each side by negative 1, and the two negatives cancel out, and x has to equal positive 3. Plug that back into the original equation, and you end up with negative 4 minus 3, which combines to give negative 7. First step in this case is to bring the 5 to the other side as a subtraction, simplify, and I've got 2x equals 8. Then I do the opposite of multiplying by 2, and I've got x equals 4. 2 times 4 is 8, plus 5 equals 13 as a check. In G part, there's actually 2 ways I could do it. If I want to stick with opposite operations, the first thing I would do, let me just list the operations. We've got something inside brackets, which normally comes first, and then I'm multiplying by 2 outside the brackets, which would come second. So reverse operations would be to divide by 2 first. I could leave the brackets or not. I don't need them once I divide both sides by 2. And I'm going to take those brackets away since I don't need them anymore. And I've got x plus 3 equals 7. Then I would bring that 3 to the other side as a subtraction, and I'd have x equals 4. As a check, put 4 in for x. 4 plus 3 is 7. 7 times 2 is 14, and that makes sense. X over 5 plus 3. So, again, reverse order of operations tells me to subtract 3 from each side as my first step. So I'd have x over 5 equals 2. And then the opposite of dividing by 5 is multiplying by 5 on both sides. And I'd get x equals 10. Let's check it. 10 divided by 5 is 2. 2 plus 3 equals 5. Again, we've got some brackets going on in this case. So we got brackets and we've got divide. Even if we didn't have the brackets, to be honest, it's kind of a shame that these brackets are here. I'm going to get rid of them because We don't usually see brackets in these types of questions, but it means the same thing even if you don't see them, even if it looks just like this. We treat the numerator as if it's in brackets anyway. So I would multiply both sides by 3 first to get rid of that, to do the opposite of dividing by 3. So I'd have 15 times 3. So x plus 4 equals 15. Then I'd bring the 4 to the other side and subtract. So it'd be x equals 11. Let's check it. 11 plus 4 is 15. 15 divided by 3 equals 5. Yep, that works. And that, it appears, is the last example. Hopefully you got the idea that we're doing the opposite operations in the opposite order, and we always check our work when we're done. Always check, just as a quick thing. Does it make sense? Does it work out?